In intrinsic silicon, a few electrons can jump the energy gap between the valence and conduction band. Having moved into the conduction band, a whole vacancy is left in the crystal structure. So as you can see, this is the figure of the band gap of an intrinsic silicon crystal. So ang intrinsic silicon crystal is mayroon siyang heat energy. Itong heat energy is known as the thermal energy. Again, intrinsic silicon crystal is mayroon siyang thermal energy at room temperature, wherein ang electrons from the valence band will going to jump the gap in between of this valence band at saka ng conduction band. So, as the electrons from the valence band were going to leave from the valence band from the valence bands to the conduction band, mayroon tayong vacancy left. So, ito yung vacancy left natin. Itong vacancy left natin is tinatawag natin itong hole. Then, yung electrons na nag-leave from valence band to the conduction band is tinatawag natin itong free electron or known as the conduction electron. So, the process is continuous. Again, kapag yung electrons from the valence band is makakuha siya ng additional energy, it will going to leave from the valence band to the conduction band. So, meron tayong matitirang isang vacancy left. So, isang vacancy hole na kung saan tinatawag natin itong electron-hole pair. Within the crystalline structure, there are two types of charge movement current. First one is the conduction band electrons are free to move under the influence of an electric field. So, one of the reasons why the conduction band electrons are free to move, this is due to the influence of this electric field. The second one, the bound valence electrons move between atoms effectively. The bound valence electrons move between atoms, effectively moving holes from one atom to another as illustrated. Holes act like capacitive charges with their own mobility. So, ito yung figure natin wherein sinabi dito na electrons move between atoms, moving holes from one atom to another. So, ito yung mga holes natin. Ito sila. Ito naman yung mga electrons natin. So, itong electron na to will going to left this hole papunta dito na hole. So, we have 1, 2, 3, 4, 5, 6, 7 na holes. So, these are these electrons. So, itong electron na to will going to leave this sixth hole papuntang fifth hole. The same also with this one. Itong electron na to will going to leave this fifth hole papuntang fourth hole. Ito naman, na electron na to will going to leave the second hole papunta dito na first hole. So, there comes the time that we have now the free electron. Again, kapag yung electrons is makakuha siya ng additional energy, it will start to leave from valence band to the conduction band. So, ito yung tinatawag natin na free electron. Itong free electron na to will going to leave this valence band or what we call the valence shell papuntang conduction band. So, let's now talk about the N-type at saka P-type semiconductor. Alam naman natin na ang semiconductor is a poor conductor. So, their conductivity will going to increase if mag-add tayo ng impurity to the intrinsic semiconductor materials. So, this process is tinatawag natin ito na duping kung saan it increase the number of the current carrier. Ano nga itong number of current carrier natin? Ito yung tinatawag natin na electrons at saka ng holes. So, again, in order to increase the number of the conduction band electrons is we're going to add an impurity. So, these impurities that we talk about is divided in two categories. So, we have this N-type at saka ng P-type. Kapag N-type, ang i-add natin na impurities is tinatawag natin itong pentavalent impurities. Kapag P-type naman is tinatawag natin itong trivalent impurities. So, semiconductors, certain impurities will change the conductivity of silicon. An impurity such as antimony has an electrons that it is not part of the bonding electrons, so is free. This creates an N materials. So, ito na yung sinasabi natin na N-type, kung saan we have these elements that can help us to use or to add as an impurity in order for us to make an N materials. So, ang isang elements na to is we have this antimony. So, alam naman natin na itong antimony has a 5 electrons. So, yung 4 na electrons niya is giband natin sa silicon na to. So, this means na giband na di ba giband natin yung apat na giband natin yung apat na electrons natin dito sa mga silicon na to. This means mayroon tayong natitirang electrons na isa. Itong electrons na to, ito yung extra electrons natin kung saan tinawag natin itong free electrons or conduction electron. So itong extra electrons na ginib up ni pentavalent atom is tinatawag natin itong donor atom. Where on the periodic table would you expect to find another element that could be used as an impurity to create an N material? So, we can find in the periodic table of an element ang mga element na magagamit natin for impurities to make an N material in below and above of the antimony. Kasi, the same sila ng, or parehas sila, again, parehas sila ng valence electron, kung saan mayroon silang 5 valence electrons. So, ang example nito are the phosphorus, antimony, at saka ng bismuth. So, let's proceed now for the p-type. So, for the p-type, an impurity such as boron leaves a vacancy in the valence band, creating a p material. Both p and n materials have energy level that are different than intrinsic silicon. So, here in the p materials, kung mayroon tayong vacancy rather, if mayroon tayong vacancy hole or vacancy left is tinatawag natin itong P material or nakaka-create na tayo ng P material. So, as you can see here in this figure of the band is mayroon tayong boron, wherein ang boron is tatlo yung valence electrons niya. So, again, ang boron is tatlo yung valence electron niya. Yung tatlong valence electrons niya is giband niya sa silicon na ito. However, kailangan natin is apat na valence electrons. Pero, again, tatlo lang yung valence electrons ni boron, kaya nakakreate tayo ng vacancy hole. Wherein itong vacancy hole is now tinatawag na natin na P material. This comes the time na nakakreate na tayo ng P materials. So again, there is a hole here. So hole from the boron atom. So mga example din ng mga element na mayroon tayo for the periodic table na makaka-create or magagamit din natin for the impurity para makakreate tayo ng P materials are the indium at saka ng gallium. So, a P-N junction. A P and N material together form a P-N junction. So, kapag ang piece of intrinsic silicon is nag-dupe yan, therefore, makaka-create tayo ng P-type at saka N-type. Again, if a field of an intrinsic silicon is duped, mayroon tayong P-type at saka N-type, wherein we can form a P-N junction at the boundary in between of that region. So, then diode is create. Didiscuss din natin yung diode na yan in the next slide. So, when the junction is formed, conduction electrons move to the P region and fall into holes. Filling a hole makes a negative ion and leaves behind a positive ion in the N region. This creates a thin region that is depleted of a free charges at the boundary. So, let's discuss itong figure na ito. So, this one. Kapag, if the P-N junction is formed, dito sa N region, ang free electrons is going to lose. As the free electrons is loses in this N region, makaka-create tayo ng positive layer of the charges near the junction. So, this positive layer of the positively charged layer is tinatawag natin itong pentavalent ion. So, as the electrons will lose, ang sa region naman sa P region naman, ang hole will going to lose. So again, as the electrons will going to move, yung holes natin at the P regions will going to lose. And then as the holes and the electrons will combine near or across the electrons, makaka-create tayo niyan ng negatively layered charge or negatively layered charge dito sa near or across this junction. So far, itong negatively layered charge na na-create natin is tinatawag natin itong tinatawag natin itong trivalent ion. Again, yung na-create natin na layer of a negatively charged layer across this junction is tinatawag natin na trivalent ion. So, itong layer of positively charged tsaka layer ng negatively charged is tinatawag natin yan na depletion region. So, what process stopped the migration of the charge across the boundary? So, the process that stops the migrations of the charge across the boundary is tinatawag natin itong barrier potential. So, a potential is built up. This is called the barrier potential that prevents further charge migration. So, the barrier potential will going to stop the charge migration. The energy diagram for the N region shows a lower potential than for the P region. So, this is the energy diagram for the depletion region and the PN junction. So, as you can see, as the diffusions continues, depletion regions is formed. And so this N region's conduction band decreases. This is because of the loss of energy, the loss of the energy electrons that diffuse across the junction and this P region. So, why do you think that the energy level in the N regions is lower than the P regions? So, the N regions tend to have a field valence shells. Conduction electrons are shielded by these electrons, so they are further away from the nucleus and have a less energy. So far, the reason is they have this less energy. That's why this N region is lower than of this P region.